Hello, today I will be teaching about the basic concepts of paper chromatography. Paper chromatography is essentially a technique used to figure out the polarities of a substance. It is important to note that paper is polar. Paper chromatography is done by putting the substance on a piece of paper and dipping the paper in some sort of liquid. For this lecture, that liquid will be nonpolar. This image shows exactly that, a piece of paper being suspended and dipped into the liquid. The substance is not present in this image, but you will see it in the next slide. What is important to understand is that the liquid will move up the paper due to capillary action. Think of it like dipping a paper towel in a bowl of water. The water will move up the paper towel, but eventually stop. The same thing happens here. However, the liquid does not move up forever due to gravity. Now, let us pretend some time has passed, and the liquid has crawled up the paper. The force of gravity prevents the liquid from moving higher than this line. So, let's zoom in on this piece of paper. Take a look at the image on the bottom left corner. This represents the paper. Notice this shape on it. That is the substance we will be analyzing. Let's say that our substance is a mixture made up of squares and triangles. What we want to do is to figure out the polarity of the square and the polarity of the triangle. Remember, we dip the paper into the liquid. The dotted line just represents where we stop submerging the paper. Anything below the dotted line is wet and is represented by diagonal lines since it's been dipped into the liquid. Again, let us pretend some time has passed and the liquid has moved upward. Now, pay attention to the image on the bottom right. This is the paper after the water has moved upwards. The line here represents where the liquid has stopped moving due to gravity. What do you notice? You should notice that our substance has separated into a square and a triangle, and that the square has traveled up further than the triangle. Try to think about what this might tell us about the polar properties of the square and triangle. This information would show us that the square is more nonpolar than the triangle. Now, why is that? Remember, the liquid is nonpolar and the paper is polar. Polar molecules are attracted to other polar molecules. If one of the substances was polar, it would be more attracted to the paper and less attracted to the liquid. Now, if one of the substances was more nonpolar, it would be less attracted to the paper and instead be more attracted to the liquid. Therefore, it would interact more with the liquid and move higher. You can think of it as when the nonpolar liquid moves upstream, it drags along with it other nonpolar molecules. So, since the square is dragged across the paper more, we can assume that the square is more nonpolar than the triangle, or that the triangle is more polar than the square. So far, we analyzed the movement of the substance's components through a nonpolar liquid. What do you think will happen if the liquid was polar instead? It would depend on how polar the liquid is compared to the paper. So, let's assume that this new liquid is much more polar than the paper. Pause and take a while to imagine the results of the experiment in this case. Even though the triangle is attracted to the paper, since the liquid is more polar than the paper, the triangle is more attracted to the liquid. As a result, the triangle moves up alongside the liquid. On the other hand, the square does not move up as much, because even though it is not very attracted to the paper, it is even less so attracted to this new liquid. I hope you found this video informative. I want to clarify that you will not see shapes in a paper chromatography experiment, but rather you will see smears. I only used shapes as a teaching example. I did not go into the technical names of the paper chromatography processes because I find that a large amount of details is harmful to learning material for the first time. If you would like to learn the more technical terms and how to perform a paper chromatography experiment, I have put 2 links in the description. If you have questions, feel free to leave a comment. If this video helped, please let me know, as this is my first video and I'm considering making more. Good luck and goodbye.